Recording in progress.
Okay, one press all that coming up, please. Let's press the dot. Dot. The dot. Use it. Press the dot. You can use the touch screen. Oh, but I'm not sharing it. I'm sharing. Not sharing as it. I don't usually do this, you know. When I come to do something, I usually just do it. But they're asking me to show you this. So I'll show you quickly. This is what pure match, right? Let me see. To prove that I just doing this until a couple students join. I'm waiting on Shadi. Don't know if she's joining. Anything from her, Kai? Hear anything?
I don't think I don't think she's home or anywhere that has internet because I sent the message, I called her and it didn't go through.
You understand it now? You good now? You sure? I'm gonna have about a bit then. So we must prove that this equal not P, right? Alright, so we're doing the left hand side. Equal. We're gonna work this out first, the man, right? This becomes not P and Q, or not P and not Q, right? Then I have to distribute all of this over this, right? Alright, so it's gonna become this. As we're doing this distribution, you treat this as if this is a times. Treat as if this is a times and treat as if this is a plus. I'm gonna distribute this over this and then over that, right? Like an expandable. Alright, so I'm gonna get like this times this first. So I'm gonna get not P and Q. This is an OR, right? Or not P. Good? That is what I get. That's one expression. Then I'm gonna get plus, which is the AND. I'm gonna know this times that. So I'm gonna get not P and Q times not Q. Alright? So now I need to distribute this over these two things. I just can spin around and I can put this here and put that here. The same thing. I'm going to distribute this over these two things. So again, I'm going to treat this as if I'm multiplying in this direction. But I'm going to treat this like a multiplier again. And this like a plus. Right? Same thing, I'm going to treat this like a multiply, this like a plus, I'm going to multiply this way. Alright. So this one first. This one check something. So they change this, right? Just to make sure that's correct. Alright, so I'm going to multiply out this now. So this is this times that first, right? I'm going to get not P or not P. Plus, which is the AND, not P or Q. Not P or Q. That's in that bracket. Okay? But not P or not P is just what? Not P. Okay? Not P or not P is just not P. P or P is P. So not P or not P is P. True or true is true. False or false is false. So this or this is whatever that is. So we know say this right. I'm not going to do that part here first. So this is and. I'm going to distribute this over these two, right? So it becomes not Q or not P. Let's try that. Not Q or not P. Plus, which is that and. this times this times. Not Q or Q. Right? So this is true. That something is the thing or not the thing, right? So this right here, so that's true, right? Don't it? All right, let's simplify some of these. So what for the Q? All right, this no, this is just not P, right? Like you that. So this is just not P and not P or Q. This bracket. And then this now is true. So it becomes true and this. So true and something is what? No. True and false. True and true is true, don't it? But true and false is false. So true and anything is what the anything is, don't it? So since this is true, true and this is just equal to that. See that? All right, so we can do that then. So recognizing that this is true, this is a truth, this is a truth. So true and anything is the other thing, guys. So that true, the answer will be true. And if this was a false, answer will be false. True and false is false. Right? True and false is false. The only time untrue, true and true is true. True and false. The only time untrue is when both of them true. True and true is true. But true and false is false. False and true, right? Right. So this becomes this then, right? So this all becomes just that, which is not Q over for the group. It's a nice question. From not Q or not. All right. We're going to expand out this now and see what we get, right? So it becomes, again, treat this out here like a plus, like a multiply, treat this like a plus, right? All right. So we're going to expand that out. So we're going to get not P and not P first, not P and not P. And then we're going to get or not P and Q. Not P and Q. And all of that, the ORing, I'm going to make it more complicated actually. Maybe there's an easier way to simplify, but let's see. Alright? Now, what is this? That is just not P. Don't go away the back to the same place. Guys, let me get back this. So that never made no sense to do about this. I'm going to get back this that I had before, which is not P. So there's something out of this. Because all I did a while ago, I went from this to this and then I go back by expanding. But not P and not P. So let me test this. This is a true. And this is a true. True and true is true, eh? False and false. It's false. And false. Indices. I'm not seeing this. You know, never made us write this. Never made us write that. Maybe there is another way. Maybe the best way to do this with a truth table. Yeah, maybe the best way to do this to be with a truth table. All the proof is with a truth table. Maybe the best way to do it is with a truth table. Everything would I do with a truth table. You have to work out the one other side there. See what is in that column. And then see what is in the not P column. And they must be equal. They must be the same. Okay? But it's supposed to be able to be done by the method that we use instead, which is the valid algebra, propositional algebra. Let me see what is happening here. No, but you still have to look and see. See, we have identifying some similarity between expressions. Oh, and so I go on. So I go on. This and this are the same thing, you know. Oh, sorry. So I go on. So this and this are the same thing, you know. Don't it? They work to be the same thing. So I know I need to do all of this. They are exactly the same thing. No, 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 they're not the same thing. Because it's a vacuum. They're not cube. So they're not the same. They're not the same. I think maybe truth table with truth values are the best way to do this. I think truth table are the best way. It work out. Let me see. The algebra proposition algebra. Yeah. Let's see. This is what I have on first line. This I have this on my first line as well, right? Yes, right? But I can see the screen online.
Yes, sir.
Yes, sir.
All right,
Yes,
so
sir,
we're
we can see the screen.
starting now. We're 1 hour late, so you know, so we're working for 2 hours straight now. But anyway, we're gonna have a makeup class tomorrow. We're gonna have a makeup class tomorrow, guys. So if you start late today, not a problem. We're gonna have a makeup class. This thing keep dropping off. I'm not gonna hotspot this. One thing, drop off again. Let me try this. Good number of them on this worksheet and then get some past papers. I said I would do past papers straight, but these are all past paper questions. Alright? Yo. Yeah man. So time we are doing we have online thing on the talk and the group echo. That's also good. Right? So one person to talk is me alone. Because people online need to hear. Alright? And the order not so good. Alright, so let's do a couple questions. So what I do them randomly. Surds, logs, indices, right? Surds, logs, indices. Can you see that clearly on the screen? All right, so this first question is for us to simplify. For us to simplify this, write it in that form. So when you see the 7 right here, you can get multiple of 7 out of that. All right? So it's like we have the square root of 28 plus the square root of 343. So this is 7 times 1. I will need to know what it's 7 times 1. So divide this by 7 for me. I will need to put that amount of, I know that this is 4 times 7. So this is the same.
49.
Good. So this one is the square root of 4 times 7 plus this one becomes the square root of 49 times 7. Right? And then the square root of the 4 is 2 because this now can be written as the square root of 4 times the square root of 7 plus this one can be written as square root of 49 and the square root of 7. The square root of the 4 right here is 2, so it becomes 2 root 7 plus the square root of the 49 is 7, this is 787. Then 2 and 7 is 9, so we get 9 root 7. And if this is the same as k root 7, means then that the k is equal to 9. But the calculator can literally put this in the calculator now, and it will give you the 9 root 7. Try that and tell me with the calculator. Try that with the calculator. The calculator should be able to give you that. 9 root 7. Got it? So the thing about it, because the calculator can give you that, in an exam room, you still have to show this work. But sometimes what the question will say, show without the use of a calculator. Show without the use of a calculator that this thing is equal to that. Alright? Alright, so this question now. It's a change of base law that must be used in there because the base is different. This is 4 and this is 2. So I want to solve this equation, right? Right here. Alright? Telling us that x is greater than 0, which it must be. I can't find the log of 0, can't find the log of a negative number. But this one is log to base 4, this one is log to base 2. And all the laws that we use basically working with the same law, the same base. You want to use the laws so that you're working with the same base. Alright? So I have log to base 4 of x is equal to 1 plus log to the base 2 of 2x. All right, now because this one has logs on both sides, I might decide to go for the option where we're trying to reduce it to log of one number equals log of another number, which therefore means that n would equal to m, and then we would solve this. That is the approach. All right. So I'm going to write this, change the base of that. So it's got the base 2. So it's going to become equal to the log of x over the log of 4. And then change the base to 2. 2 and 2. That's what this becomes. We change the base to 2. All right. 1 can also be written as log to base 2. So let me show you one time now. If you have a number you want to convert it into log, let's say I have 2 for example, let's say I have the number 3. And I want to convert it into log to base 2. All I need to do with the 3 in order to convert it into log to base 2 is multiply it by log to base 2 of 2. Because remember, like I'm multiplying it by 1. And then the 3 comes up here. See that? So what was 3 before would now become log to base 2 of 2 cubed, which is log to base 2 of 8. So if I had a 3, I could replace it with log to base 2 of 8 if I want to turn it into logs. But this is just 1. So 1 is just log to base 2 of 2. Right? I decided that I want to turn this equation into this form. So I need to get rid of this 1. I'm going to write as log to base 2 of 2. All right? So let me take this out first. So this becomes equal to log to base 2 of 2. That's what the 1 is. Plus log to base 2 of 2x. All right? And this log to base 2 of 4 is actually equal to 2. Can you appreciate that is 2? Right? Because this 4 is the same as the 4 right here. It's the same as 2 squared. Squared come to the front. Let me write it down here. Why it is 2. So we have log to base 2 of 4. The log to base 2 of 4 is the same as the log to base 2 of 2 squared. This 2 comes to the front. So then it becomes 2 times log to base 2 of 2. And log to base 2 of 2 is 1. So it becomes 2 times 1, which is 2. That's why this under here is 2. Right? That under there is 2. So I'm going to write this there. And if you divide by a 2, it's like a multiply by a half, right? If you divide by a 2, it's a multiply by a half. I'm going to write this as half log to base 2 of x equals, then this plus now means that I'm going to be multiplying these values under the log to base 2, right? So this becomes log to base 2 of 4x, because I multiply this times this to get the 4x. Right? What do I do with this half? Bring it up here as a power. Or I can multiply across here the 2 and bring it up here as a square. Whichever way, doesn't matter. Let me bring it up here as a power. This, I'm going to bring it up here as a power. So this is going to become log to base 2 of x to the half equals log to base 2 of 4x. Yeah? So it means that x to the half equals 4x, don't it? So you can say therefore. So we reach this now, basically we reach this now, right? When we're here, it means that we have reached this. Alright? So this then becomes, so you can say therefore, x to the half is equal to 4x. Then get rid of the half power, square both sides. Square both sides. So we square this, becomes x. When we square this, you get 16x squared. Right? Now watch this now. You can divide by x this time, So normally when you're solving an equation, you do not cancel out what you are trying to find. You don't divide it out. You don't cancel it out. So for example, you and I would say, keep divide this by side by x and divide that side by x. You don't do that. Because generally speaking, you don't know if x is 0. And you cannot divide by 0. So normally you don't divide or cancel out the thing that you are trying to find. The only reason why I'm able to divide by x this time is because they told us this, that x is greater than 0 right here. So because we know that x is greater than 0, it is not 0. That is why we can divide it. Because otherwise you would solve. Let me show you 2 ways to do it. Because one way is that you will get x equals 0 as a value which you cannot accept. So I'm going to do it 2 ways right here. So I'm going to solve x equals 16x squared 2 ways. I'm going to say since x is greater than 0, we can divide by the x. If you divide by the x, this side will become 1. This side will become 16x. I divide by x. And so the x will be equal to 1 over 16. That is the answer. If you don't want to divide by the x because you don't know, let's say you didn't know that x was not 0, was not greater than 0. Then to solve this, you would turn it into a quadratic and factorize. So I would, for example, bring this x over here, and I would get 0 equals 16x squared minus x. Then I would factorize the x out of that, because that's the only factor in this is x. So I would get 0 equals x into 16x minus 1. So then I will be getting x equals 0, getting x equals 0, or 16x minus 1 equals 0. That? So this x equals 0 is an answer now. We can accept it. It's not valid, because they told us here that x must be greater than 0. In addition to that, another reason why you can't accept 0, because this now is asking you to find the log of 0 if x is 0, but you can't find the log of 0. So whichever way you take it, it cannot accept this answer. So this would not be valid. This one would not be valid. Not valid. And then this now we're gonna give us the same answer, that x equals 1 over 60. This one gonna give us x equals 1 over 60, which is the same thing we have right here. So in this case, this was the easier way to do it. Because they gave us this information. Because they gave us this information, it means that we can divide by the x, because we know it is not 0. The only time you can't divide by a value or a variable is when you don't know whether or not it is 0. So generally speaking, you do not cancel out of an equation something that you're trying to find, as we did right here. That could cancel the x from both sides, divide on x. Alright? Because we know that it is not 0, we can divide by it. Can't divide by it because we know it is not 0. But okay with that? In the classroom and online?
Yes, sir.
Yes, sir.
Alright. Alright, let's look at another question. Let's look at this pair of simultaneous equations. This one. In logs. Simultaneous equations in logs. So you're going to solve these 2 equations simultaneously, guys. You need to get the logs out of them. You need to turn them into what we call Cartesian equations. Those are the equations in x and y alone. You don't want the logs in there. So therefore, what you have to do, you want to take this first one, simplify it down the same way that we said. One have 2 options. To get the logs out of it, I'm going to do the same thing with the second equation. And then we get 2 normal Cartesian equations now, then you solve the Cartesian equations simultaneously. All right, that's what we're gonna do. All right, let's go. All right, so they give us these two equations. I'm gonna do the first one. Look at the first one and simplify it first. Log of x minus 1 plus 2 times the log of y equals 2 times the log of 3. But this one, since I have log on this side and log on this side, I'm going to use the approach where I'm going to bring it down to log of a number equal log of another number, which means that the two numbers are equal. This is the approach that I'm using. All right? So first thing I'm going to do is move this 2 and put it up here. That's the third lot I looked at. I move the power, all right? And then I'm also going to move this 2 and put it up here as a power. All right? You have to know those laws like the back of your hand. So this then becomes the log of x minus 1 plus the log of y squared. We'll move up the 2, it becomes y squared. And then this now becomes the log of 9. When I carry the 2, it becomes 3 squared is 9. And this now on this side means that I take the log of the product of these two things. The plus here means that I'm going to log the product. So it becomes the log of x minus 1 y squared equals the log of 9. Which then means that this thing equals 9. So we can draw the conclusion. So we can say x minus 1 y squared is equal to 9. This really is our first equation now. Need another equation from this one. This is pretty easy. But for that one now, the second one, we have the log of x, wrong color. So the log of x plus the log of y equals the log of 6. This side becomes the log of xy. So get the log of xy equals the log of 6. Therefore means that xy equals 6. Xy equals 6. Alright? Xy equals 6. So since xy equals 6, this is my second equation. I can substitute for xy in this, you know. Look what I'm gonna do. Look what I'm gonna do. Let me shift this down and just show you something. I'm gonna generate the xy in this up here. Let me take the box off, so I'm gonna change. So I'm gonna expand with the y. So I'm gonna get xy squared minus y squared equals 9. So this xy squared is the same as xy times y now, minus y squared equals 9. So I'm going with this. Everybody see where I'm going with this?
Yes, sir.
Good. You see right here we have the xy. I'm going to replace it with 6. I'm going to take this. But this is saying xy equals 6. I'm going to substitute it for this xy right here. Right? Go for purple now. When I make that substitution, this equation becomes 6y minus y squared equals 9. Good? That's a positive equation to solve now. When I'm solving positive equations, I want my y squared to be positive, my squared term to be positive. So I'm going to transpose everything over that side. So when I carry over the negative y squared over there, it becomes a positive y squared. When I carry the 6y over there, it becomes minus 6y. I know 9 is already over there, plus 9. I would have equals 0 here, but I can write it here instead. No problem, I take off this one. And this now factorizes easily. Y, 3 and 3 minus minus equals 0. So y is equal to 3 repeated. And since y is equal to 3, when I substitute y equal to 3 right here, so that x equals 2, don't it? But 6 divided by 3 is 2. See that? So 6 equals x equals 2. So y equals 3 repeated and x equals 2. Any question on that?
No, sir.
Good. Good. All right. Now we have this equation to solve. That's this guy's quadratic equation, right? Quadratic equation. It's a lot of admaths. It's a lot of, but you saw it on pure maths as well, right? It's on both admaths and pure maths. All right, let's start that one. Let's go. All right, so we have this system. 4 to the x minus 3 times 2 to the x plus 1 plus 8 equals 0. Let's do it part by part, just for explanation purposes. So this 4 to the x, I'm going to work it out the way. All this can become something, an equation in 2 to the x. That's what it becomes. An equation in 2 to the x. That's what it's going to become. All right? So let's see how it becomes an equation in 2 to the x. Firstly, the 4x, 4 to the x right there is the same as 2 squared to the x, which is the same as 2 to the x all squared. Because this time it's a 2x here, just as how that time that a 2x. So we can literally switch these around. So I'm going to replace this with 2 to the x all squared. And then this now, are the whole of this expression, this part of it first. So the 2 to the x plus 1 is actually the same as 2 to the x times 2 to the 1. Eh? Using the laws of blocks. And the 2 to the 1 now, so it really becomes 2 times 2 to the x, don't it? That's what this inside the bracket becomes, you know. But then we're multiplying it by the 3 there, so it actually becomes 6. See that? So then let's write it out. This, as we said, becomes this thing right here, 2 to the x squared. 2 to the x all squared. Minus, when I multiply this inside here, so by the 3, I'm going to get 6, 2 to the x. I'm going to minus 6, 2 to the x, plus 8 equals 0. But I say that, then this is just a quadratic in x. I'm not going to call it y anymore. We have to learn how to advance ourselves. I'm not going to call it y anymore. We're going to factorize it. Factors of 8 that add to 6 is 2 and 4. This means also that the 2 signs in the bracket are the same. Both of them are negative. So this can be factorized easily like this. Two to the x, 2 to the x are the factors of this. Factors of 8 that add to 6, 2 and 4. 2 signs in the bracket are the same. That's what a plus means. And both of them are negative. Negative, negative. This one means that 2 to the x is equal to 2, or this one means that 2 to the x is equal to 4. Now this 2 is same as 2 to the 1, so this will become 2 to the x equals 2 to the 1, or 2 to the x equal, this 4 is same as 2 squared. So then it means that x equals 2 or x equals 1. That's the solution. X equals 1 or x equals 2. That is it. Any question on that? That's advanced level work. That's one. Advanced level work. Let's look at this now. You see, our question without using a calculator. Find the exact value of this. Meaning that you cannot use a calculator on it. When you finish, exact value means you can leave it in Surds. Alright? Let's go. So when I look at this right here now, guys, I'm seeing the difference of two squares. Because if I call inside here, so x, see it as x squared minus y squared. And look at it that way. So everything inside here says x, everything inside here says y. What can I say that? Got it. See that x squared minus y squared. Right? Difference of two squares. X squared minus y squared. So inside here says x, inside here says y. Let's look at it. So if I work that's x squared minus y squared, what x squared minus y squared equal to? It equals to x minus y times x plus y. What does this mean? It means that I need the difference between this and this bracket. And I need a sum of the same two things inside this bracket. All right, the difference first in this bracket equals. So look now, I'm doing this minus this. So the root 75 minus root 75 gone. And then root 12 minus a negative root 12 actually give me 2 root 12. So I'm going to get 2 root 12 in the first bracket. Times. I need the sum of them. So I'm now adding this and this. So root 25, root 75 plus root 75 is 2 root 75. Root 12 and minus root 12 eliminate each other. So inside the bracket, I'm going to get 2 root 75. See that? So I end up getting 2 times 2 is 4. This root 12 is the same as 4 times 3. So I'm going to write the square root of 4 times 3. This root 75 is the same as 3 times 25. So I'm going to write as the square root of 25 times 3. Right? Then now the square root of this 4 is 2. Square root of this 25 is 5. Look what I'm going to get 4 times 2 times square root of 3. That's what I get from this one. Good? And then square root of 25 is 5. So I'm going to get 5 times the square root of 3. And the second one, so I put them in brackets. No, leave the 4 on the outside. Leave the 4. Let me leave the 4 on the outside here. So let's color code. I get this from this, and I get this from that. Then in terms of a final value, it becomes 4 times 2 times 5. That's what? That's 40, right? 4 2 is 8, 8 5 is 40. So it becomes 40 times root 3 times root 3 is 3. So the final answer is 120. What you can do to check if it is correct is actually put all of this in the calculator. It's going to be equal to 120. Try it now. Try. Put it in the calculator for me and see if you get 120. So this is an example of simplifying surds. This one is an example of simplifying surds. . People online, okay?
Yes, sir.
Get to the calculator. Try to the calculator to me. Get it to the calculator, 120. Good. 120. This is an example of simplifying search. All these questions, I wanted to work them over again. I wanted to work the questions over again. All right? Just practicing some of these, but I wanted to work them over again. Can I move on? All right. So we're gonna do this one now. Just indices. So realize that all those base numbers can be brought to 3, base 3, don't it? Can be written as powers of 3 then. Remember, when you have a power that's a fraction, the value on the numerator is your power, the value on the denominator is your root, right? Most times you take the root first, because the root makes the number smaller before you apply the power. All right. So I'm going to work with this expression and see what it becomes. The total calculator. So it's 27 to the quarter times 9 to the 3 over 8 times 81 to the 1 over 8. All these base numbers can be written as powers of 3. Powers of 3. So this 27 I'm going to write as 3 cubed. So I get 3 cubed to the quarter times. This 9 is 3 squared. So I get 3 squared to the 3 over 8 times. This now is 3 to the 4th power. 81 is 3 to the 4th power. That's 3 times 3 is 9. Another 2 is 3 times 3 is 9. 9 is 81. So this is 3 to the 4th power to the 1 over 8. So everything is now base 3. Here I'm going to multiply these powers. I'm going to get 3 to the 3 over 4 times. Multiply these powers. I'm going to get 3 to the 6 over 8, which is 3 over 4 times. Multiply these two, I'm going to get 4 over 8, which is a half. But half is the same as, half is 1 over 2, right? But since these are already over 2 over 4, I'm going to write it as 3 to the 2 over 4. All of them have the same thing, right? When I multiply numbers, the same bases with the same power, I have to add these powers, don't it? So, add the powers. So it becomes 3 to the 3 over 4 plus 3 over 4 plus 2 over 4, which becomes 3 to the 8 over 4. 8 over 4 is 2, don't it? It becomes 3 squared, and 3 squared is 9. That's what we get. Simplify it all the way down to 9. All right, guys. Try this question for me. The question says, I want to give you 5 minutes to do. Question says, using a substitution by substituting y equal log to base 2 of x. Y equal log to base 2 of x. Right? So we will say log to base 2 of x, for example, here is a y. But note that this is x to the half, x square root of x. Square root of x same as x to the half. We must give it the hint. Square root of x same as x to the half, right? Solve this equation for me. Within 5 minutes. Solve this equation for me using this as a substitution. Y equals log to base 2 of x. Remember, square root means power half. Square root is power half. I'm going to pause the video, give you 5 minutes to try. All right, let's. Yeah, let's try. Try it for me, please. Don't matter if we get the right or let's try. Okay, guys, let's do this. You finished with the solution?
No, sir.
All right. So they give us this log to base 2 of x, square root of that equals log to base 2 of the square root of x. And they tell us to use y equal log to base 2 of x. Now, first thing, I'm not going to work with the square root. I'm going to write this as to the half, and this one as to the half. So I'm going to write this as log to base 2 of x to the half equals log to base 2 of x to the half. This half can come to the front. Huh? Now inside this is really y to the half. When I bring this half to the front, it becomes going to become half y. So I'm going to write log to base 2 of x to the half equals half log to base 2 of x. I can make the substitution now, right? I'm going to say put y equals log to base 2 of x to begin with. So therefore, it reduces to y to the half, this becomes y to the half equals half y. And so we get to know. We're not going to work with half four, so we're going to square both sides. Don't it? Square both sides. So if we square both sides, this side becomes y, and this side becomes a quarter y squared. Good? Don't work with fractions, we're going to get 4y equals y squared. That becomes a quadratic, which then carry this over this side and subtract. We get y squared minus 4y equals 0. So factorize the y. Y bracket y minus 4 equals 0. So then it is y equals 0 or y equals 4. But y is log the base 2 of x. So then this then is log the base 2 of x equals 0 or log the base 2 of x equals 4. Easy. This x is equal to 2 raised to the power 0. Number equal base raised to power. The x must be 1. Log of 1 is 0, don't it? X equals 2 to the 0. X equals 1. Or this x equals 2 to the power 4. X equals 2 raised to the power 4. 2 to the power 4 is 16. X equals 1 or x equals 16. That's it. Any questions on that? Online, everybody okay?
Yes, sir.
Yes, sir. Yes, sir.
All right. All right, let me see this thing. I'll leave that one for you. I'm going to start skipping out some of them, all right? But I want to jump to some past papers. Let me see if there's any interesting one left here. All right, so we're going to do Surds. So let me do this one that has some Surds in it. This one. This one right here. I'm going to do this one. This, that's an Indices. And then this one is a Surds, right? Let's do A and B. This one also has some Surds in it. And do that one as well. And then we switch. Some past papers. Let me see. Let's see if there's any interesting one there. That might be this question after this. We'll jump to the past papers. Let me look at that one. Right. We're gonna look at, we're gonna see some nice questions on some past papers. going to do this. I'm going to do this. I want to look at some past papers. This one look nice though. Show without a calculator that this thing equals that. And then this thing equals 4. Can we look at this one? How many are there that have one? 1, 2, 3. All right. We're going to do 3 questions. And then we're going to look at some past papers. Pure maths and add maths. I'm going to start out with the pure maths first. And then we look at some add maths. All right? So let's look at this question first right here. The first one that you have marked here. Let's go. Remember, in all these examples that I'm doing, you are to redo them. You are to redo all the examples that I do. Do them over. Redo the questions. Use the video to help you. Pause, rewind, and play the video. If you have to work one question 3, 4 times until you can work it smoothly, that's what you do. Right? Redo all these questions that I did as examples. Then you go and try the others. So the others on this that I did not do, you can go and try those afterwards. All right? And they'll become easier for you because, you know, you can do the ones that I've done already. All right, let's look at the first one, part A. Part A says solve for x. Solve means find the unknown, which is x, right? That clearly is an indices question. Indices, basic stuff. 3 to the x all squared equals 27 to the x minus 2. Bring everything to base 3. Bring 2 sides to base 3. So in this case, we want to get 3 to the something equals 3 to the something else, which then would mean that the 2 something them equal, right? That's what you're trying to do. Bring both sides to base 3. All right, so this becomes, we're going to multiply these 2, you get 3 to the 2x right here. Multiply these 2, you get 3 to the 2x. 3 to the 2x. And this 27 now is 3 cubed. So it's 3 cubed to the x minus 2. And we're going to multiply these again. So I get 3 to the 2x equals 3 to the 3x minus 6. Once you have that, same base on both sides, the 2 powers must be equal. Therefore, 2x equals 3x minus 6. Q over this and subtract the q over that and add it. I'm going to get x over here equals 6 over there. So x equals 6. Do that. X equals 6. That one okay, right? Nice and easy. Nice and easy. Applying the laws of indices. Let's look at this one. This one. It says, express this in this form. They basically want us to rationalize the denominator. That's what it is. Rationalize the denominator. Express it in this form. All right? So we want to rationalize the denominator. Let's go. I think this is first one we get to practice in within the topic. So we have 5 minus root 3 over 2 plus root 3. We want to rationalize the denominator. You multiply it by its conjugate to set up the difference of 2 squares. We're going to multiply this, the denominator by 2. Since it's the plus, we're going to put a minus root 3. Since you multiply the denominator by 2 minus root 3, we have to multiply the numerator by the same thing. 2 minus root 3. All right? So the denominator becomes the difference of 2 squared, and then here now multiply these two things. Ready? This becomes equal to. Let's do the denominator first. Becomes this squared minus this squared. 2 squared minus root 3 squared. The numerator now becomes the product of this and that. Good? So it is like we're doing the 5 times each of these first, and then the minus root 3 times each of these next, right? So let's do it with the 5 first. So it's 5 times 2 and 5 times minus root 3. So we're going to get 10 minus 5 root 3. And we use a 5, right? We're going to use minus root 3 now. So minus root 3 times this first and then times that. So minus root 3 times the 2 give me minus 2 root 3. And then minus root 3 times minus root 3 give me plus 3. So root 3 squared is 3. So I'm getting plus 3. Better go to that. Online, better go to that.
Yes, sir.
All right, consolidate the values now. This and this is 13, don't it? This becomes minus 7 root 3 all over. This is 4 minus 3, which is 1. So the answer is 13 minus 7 root 3, which is in this form that they told us. So as for the values, the x would be 13 and the y would be negative 7 because they have a plus y. They have a plus y in the question right here. We get minus root 7. So they wanted the value, that's what they would be. All right, beautiful. 1 down on this paper, 2 to go. And then we're gonna jump to some past papers. We're past papers from 2012. I want to come up. I did a couple in the class. Started with pyramids. After we finish the pyramids, we have time. We're gonna jump to some advanced. All right. The higher level first. I want the lower level to become easy. All right, let's do this question now. We have to show that this equals this. Again, the matter of rationalizing the denominator, that's what it is. Rationalizing the denominator. That's what that is all about, right? So let's go. So to prove that this equals this, it is like you start to the left side. You rationalize the denominator and then show that it becomes that. Let's go. So for part 1, I have root 6 plus root 2 over root 6 minus root 2. I want to rationalize the denominator and multiply by its conjugate. I'm going to multiply the denominator by the conjugate of the denominator, which is root 6. Since this is a minus, I'm going to put a plus root 2 to set up the difference of 2 squares. But since I multiply the denominator by that thing, I can multiply the numerator by the same thing. Root 6 plus root 2. So you notice that the numerator becomes a perfect square, right? But the denominator has the difference of 2 squares, right? So let's go and do that. So this becomes equal to the denominator first is the difference of 2 squares. So it becomes root 6 squared minus root 2 squared. The numerator becomes root 6 plus root 2 all squared. Let's write that out first. Which is equal to, we're going to expand this perfect square now. Expand a perfect square, remember you get the first term squared. First term squared is 6. Then you get twice the product of the 2. Multiply these two things, I'm going to get root 12. Root 6 times root 2 is root 12. Then I double that, so my middle term is 2 root 12. And then I square that one, I get plus 2. That's the first term squared, twice the product of the 2, second term squared. Then now under here, root 6 squared is 6 minus root 2 squared is 2. All right. Well, this answer has a root 3 in it right here. So let me continue. All right. So this and this gives me 8 plus 2 times. So this 12 is the same as 4 times 3. All over, this becomes 4. Then this root 4 is actually equal to 2, don't it? Root 4 is 2. Right, the root 4 on the day becomes a 2. That's right. The root 4 is actually 2. And then the 2 times 2 is 4. The 2 times that root 4, which is 2, is going to give me 4. So it's going to work out to be 8 plus 4 root 3 all over 4. So when I divide this by the 4, I get 2. When I divide this by the 4's cancel and give me plus root 3. Therefore shown. I've shown it. But okay with that?
Yes, sir.
Right. Then we come to part 2 now, right here. Let's look at part 2 carefully. So this and this is the same thing. So we can drop this here so for that, right? Good? But they're the same thing, right? But if you look carefully now, this is actually the reciprocal of this. Because you see, this minus is now up here. And this plus is now down there. So it's actually reciprocal. So in part 2, what we really have is this. In part 2, what we really have, part 2 becomes 2 plus root 3 plus 1 over 2 plus root 3. But I get that? But I get that? But this is this, same as that. We just did it here. The same thing up here. That means that we can take this one thing. We can take this and replace that. And if you look at it now, this is just a reciprocal of that. So therefore it is a reciprocal of that. That's why we put it as this, 1 over 2 plus root 3. That's what we're working on now, you know. 2 plus root 3 plus 1 over 2 plus root 3. I'm going to rationalize this one, this denominator. So that one, I'm going to take it and again multiply the denominator by 2 minus root 3 and so multiply the numerator by the same 2 minus root 3. This one, I'm doing that too. Good? So let's continue. So then now, this stays as it is. 2 plus root 3 plus the denominator again is the difference of 2 squares. So I write that first. It becomes 2 squared, which is 4, minus root 3 squared, which is 3. The numerator stays 1 times this, which is 2 minus root 3. Under here says 1. So this reduces to 2 plus root 3 plus 2 minus root 3. These are eliminated. And then the 2 and 2 give me 4. That I said it was 4. So there, 4. So therefore shown again. So that is some practice on rationalizing. Rationalizing. It's very easy. Use a conjugate. Most of it is just simplifying and what have you. Just some operations after that. Very easy stuff. Right? Rationalize, use a conjugate. You multiply by a conjugate, and you form the difference of 2 squares. So I have one more question on this sheet that I'm going to do before I jump to past papers. These are all past papers too, you know. Like all of these, all of past papers. Let us do this one now. Part A and part B. Let's go. Alright, this one. So part A wants us to solve these two equations simultaneously. That's what it is, you know. Given that this equals that and this equals that, calculate the value of x and y. Simultaneous equations are this and this. One is in the form of indices, one is in the form of logs. Again, we want to get two Cartesian equations out of them and solve the Cartesian equations. Let's start with the first one, which is 2 to the x times 4 to the y equals 128. I'm going to bring everything to base 2 so I can get all the indices out of it. Bring everything to base 2. This stays as 2 to the x. It's already base 2. This 4 is 2 squared. So it's like I have 2 squared raised to the power y. So I multiply the power, so then I can replace it as 2 to the 2y. What I go to that? So this becomes 2 to the 2y equals 128 is what? 2 to the what? 2 to the 7th power. Check it for me. 128. 2 to the 7th power. Is that correct? Yes. 128 is 2 to the 7th power. Then here now I add the indices, add the powers, add the powers. So this left side becomes 2 to the x plus 2y equals 2 to the 7th power. Therefore, this equals this. My first equation. X plus 2y equals 7. First equation. I'm going to work on my second equation now. Again, I have logs on both sides. It's the easiest one still. Because I'm just going to multiply the 2 times 5 and get 10. So the second equation, which is, let's do that one in purple. Second equation, which is log of 4x minus y equals log of 2 plus log of 5. This becomes the log of 2 times 5, right? So I get the log of 4x minus y, 4x minus y equals the log of 10. I multiply the 2 times 5, I get log of 10. Then you said this equals 10. So I get 4x minus y equals 10. It's my second equation. And so now I just need to solve those two equations simultaneously, don't it? I can do it by multiplying this one by 2 to create a 2y, as that one is. So I multiply this one by 2. I'm gonna get 8x. Come back for the curve. 8x minus 2y equals 20. I want to make this my second equation instead. Then when I add these two equations, the y is eliminated. So next I'm going to add 1 and 2. The equation 1 plus 2, I'm going to end up getting x plus 8x is 9x. 2y and the minus 2y are eliminated equals 7 and 20 is 27. So clearly, the x is equal to 3. And if x is equal to 3, we can substitute x equals 3 right here. But x equals 3. So we're going to get 3 plus 2y equals 7. So that's an answer. So over the 3, we're going to get 4. That means that y equals 2. Because 2 times 2 is 4. Those are my answers. X equals 3, y equals 2. These are my answers. That's it. But you know, get two Cartesian equations from what they give you. Right? And then you solve these two equations simultaneously. All right. This one now. Again, I have logs on both sides. I'm going to work it and get logs on both sides. Log of n equals log of n. So therefore, the m and the n equal. Use that approach. So log of 1 minus 2x minus 2 times the log of x equals 1 minus the log of 1 minus 5x. I want to take this to and move it up here first. I don't want to multiply in there. So I'm going to get the log of 1 minus 2x minus log of x squared. See this 1? All right, so this minus 7 over here, so I can bring it over here and add it. So I'm going to get plus the log of 1 minus 5x. Same difference, but they make it stay equals this 1. I'm going to consolidate everything here. So this minus in front of this means divide. This plus in front of this means that I multiply, right? So this all becomes the log of this and this multiplying together. 1 minus 2x times 1 minus 5x. And then this minus in front of this log x squared means that I have to divide by x squared. And everything equals 1. When we say LG, means that the base is 10. Base is 10. If the log of a number is 1, it means that the number and the base equal. Or we can say raise 10 to the power 1. Still 10. Anyway, you take it, this thing is equal to 10. So we can write that. So we get 1 minus 2x bracket 1 minus 5x over x squared equals 10. So you're solving a quadratic equation, really. When we transpose it out, simplify it to the standard form, right? We're going to multiply this x squared over here so by the 10 and expand this bracket. So 1 times 1 is 1. Then the middle term is the far product and the near product. Far product is 5x, near product is 2x. They add to 7x, negative 7x. And then negative 2x times negative 5x give me plus 10x squared. Then this minus this x squared come over here, multiply over there, giving me 10x squared over there as well. And so they eliminate each other. So I end up getting 1 minus 7x equals 0. And so x equals 1 over 7. Carry this over here, so make it positive and then divide by the 7. X equals 1 over 7. That is it. Any questions on that? Online? Nobody? Nobody okay?
Yes, sir.
It's very important that you redo the questions. We'll do that last one there now on this paper. All right? Okay, let's go. All right. So when I look at these, I can't use an indices method because they don't, they can't, they're not, we can't bring them to the same base. This is a whole number, right? So one is base 3 and one is base 4. But the thing that we want to find is in the power. So when the thing that you want to find is in the power, you must take logs to get it out of the power. I'm going to do it like a pure math student. I'm going to use LN. C-sec, add math, use log to base 10. So I have 3y plus 1, 3 to the y plus 1 equals 4 to the y. First thing you do, take ln on both sides. It becomes the ln of 3 to the y plus 1 equals ln of 4 to the y. Now, this now is going to come to the front as a power. We have to bracket it. You have to put y plus 1 in a bracket as a whole ln 3. If you don't do that and leave this, you might go forward and just keep these as two separate terms, which they are not supposed to be two separate terms. Understand? That is why you need to bracket the power. The entire power is multiplied by the ln3. Then this y comes to the front. You get y ln4. I'm trying to find y. So to expand, group all the terms of y on one side. Expand this side, I get y ln3 plus ln3 equals y ln4. I'm going to take this over here and subtract it. So I'm going to get ln3 equals y ln4 minus y ln3. I can factorize the y out of these two terms now. So I get ln3 equals y bracket ln4 minus ln3. I can take all of this and just divide it on this side. So I get y equals ln3 over ln4 minus ln3. That is my answer for y. So the key thing here, guys, when you move this thing out of the power, you bracket it up. It has to come out as a whole power. Don't bring it out separate. Make a mistake. As separate values. Any questions on that? But okay, online, not hearing from certain people, one person keep answering all the time. Not hearing. All right, Mr. Jackson, Mr. Ibam's not hearing from you. And Kaya, let's see. Are you there?
Yes.
Okay. Mr. Ibams, are you there? Yes, that's a no. Mr. Giovanni.
Yes, sir, I'm here.
All right, go. That's a door like about that. I cannot see who's there from you. Huh? Can I get one? Say that. Say that. And there's a book for pyramids. And I'm going to give for a book. For all the past people, all the past people are going to get through here. Yeah, and you get that, you get from the sun, yeah. That much part is from the same book from last year, but you also get a few months. And you're gonna get past papers right through the end of the year. Multiple choice and paper too. All right, so let's say I'm gonna question with the payment, we're gonna pay for. So I'm gonna question the pay when the time comes. All right, so just be mindful of that. Just be mindful of that. So I'm gonna question the payment when the time comes, just to see. So since we want to nitpick and go all the way down to the mining with the details and find, because thing about it as a teacher, I give so much extra hours and all the things there. You understand me? But you want to go right down to the wire, just put the payment and what you get in, no problem. You'll always get more than you pay. You'll always get more than you pay for. Always. About just one book. One book. And get past papers right through here. Anyway, let's jump on some past papers now. Let's jump on some past papers. Um, Let's jump on some vast papers now. Pure maths. One vast papers. All right, we're gonna do some paper twos. We're gonna start from 2012 and work our way up. All right. I'm gonna search for the surge logs and indices in those papers. Work our way up. Here's a nice question right here. Indices. I'm going up on screen. All right. This one says, find the positive integers x and y such that this thing is equal to that thing. Nice question. Find the positive integers x and y, which is such that this thing is equal to that thing. All right? So basically, when you expand this out, it is supposed to be equal to that. But what are the values of x and y? There's a comparison thing you have to do. You have to expand this out, see what it becomes, and then you compare the values. I'm going to set up the equations again. So let's go. So I have the root of x plus the root of y, all squared. They are telling us that this is the same as 16 plus root 240. Let's work the left-hand side first and see what it is actually. This side, we're expanding. Now this is expanded. Let's work this side first. So we're expanding this perfect square. Becomes the first term square, which is x, plus twice the product of the 2, plus twice the product of the 2. So multiply these two things and double the result. We're going to get 2 root xy. And then the second term square is a plus y. That's expanded form. So we're trying to compare this with this now. So these are the two parts that are rational. This part is the irrational part. I'm going to write this as x plus y plus 2 root xy. Because I want this and this to look alike, I'm going to write this 2 as root 4. Right? But I said that I'm going to write this 2 as root. I don't have to still know. I can work it same way, but just to have some skills. Demonstrate the skills that you can have. I'm going to write this 2 as root 4. So I'm going to write x plus y plus root 4xy. See that? See that? Well, root 4 is 2. So I write the 2 as root 4. But I'm trying to make this look like that in the expanded form. Therefore now means that this x plus y is equal to 16. And it also means that this under the square root is equal to root 240. Don't it? See that? We'll compare it. We can write that there. That's okay. Based on that, let's do it in black. Based on that, you can see that x plus y, so therefore, x plus y, and we can say that 4xy is 240. Multiply this. If you divide by the 4, we're going to get 60. So you get xy equals 60. So we will have these two equations solved now. And these two equations are really very easy to solve because we want the product to be 60 and the sum to be 16. What are the two values where the product is 60 and the sum is 16? Product is 60 and the sum is 16. Which two values are there?
10 and 6.
10 and 6. So remember now, if x is 6, then y is 10. And if x is 10, then y is 6, don't it? So it means that your solution really is that x equals 6, y equals 10, or it can be x equals 10, y equals 6. This is your answer. This one easy, you don't have to worry about. Otherwise, you have to solve them simultaneously, those two equations. But with those values, you don't have to. It's like them give me 4, it's like them give me xy, for example. Xy equals 12 and x plus y equals 7. That's a must 3 and 4. What is it? Must 3 and 4. That 3 4 is 12 and 3 plus 4 is 7, right? Good. So sometimes the value is just easy to see like that, as it is this way. In this one. Any questions on that? That was on 2012, guys. 2012. That was the only Surds question. Let me see if there's a logs question on it. Let's see. Let's see if there's any logs on it. Any logs. 2012. This is function. Aha, there you go. There's a logs question for you. But okay with this one on the screen? But all right with that?
Yes, sir.
All right. So let's look at this next question now. It says, without using a calculator, you must calculate the value of this thing right here. Without using a calculator. Say you set this question and set it on add maths, then set it on pure maths. Same question and change it up a little bit, but it's the same thing all the time. That question set multiple times already. So using the laws of logs, let's look at it. Let's look at it clearly. It means that all of this, these are different colors. All of this is going to become the log, 1 log to the base 10 of this times this times this times this times that. And when you add logs, you become the log of the product. So, don't it? So if I use the red, then this thing becomes equal to the log to base 10 of the product of all those values. A third times 3/5 times 5/7 times 7/9 times 9/10. And then all these numbers cancel each other. 3 cancel 3, 5 cancel 5, 7 cancel 7, 9 cancel 9. You're left with 1/10. See that? I'm going to take off all those marks. I don't like to mark up my work. But it becomes log to base 10 of 1/10. It's actually -1. I'm not negative 1. But it's 1/10 is same as 10 to the minus 1. So it becomes equal to log to base 10 of 10 to the minus 1. Minus 1 can come to the front. When minus 1 comes to the front, it becomes minus 1 times the log of 10 to base 10. Log of 10 to base 10 is 1. So it's equals minus 1. Another way that this can be looked at, another way, let's put it in a different color. Or you can look at this as, since this is a quotient, look at it as the log of 1 to base 10 minus the log of 10 to base 10. Okay. I divide the subtract. Log of 1 is 0. And the log of 10 to base 10 is 1. It actually becomes equal to 0 minus 1. Still is -1. So we're going to do it way in blue or this way that will have it in red. But that is the answer. And believe it or not, this question is almost the same thing, you know. Because this is a symbol for summation, it's a summation. Ready? But I have that on the screen. Screenshot it or whatever you're doing.
Yes, sir.
All right, let's look at the next one now. This next one. All right. What do I got it is? Sigma means sum. So I can plug in the one first. You plug in the one first, it becomes log to base 10 of 1 over 2. You plug in the 2, you get plus log to base 10 of 2 over 3. You plug in the 3, you get plus log to base 10 of 3 over 4. Don't it? And it continues all the way up until you reach 99. 99. So the last value is log to base 10 of 99 over 100. But the value before that would have been 98. So in front of that, you would have log to base 10 of 98 over 99. And the trend continues backwards. So it's a similar question to what we just did. It all becomes log to base 10 of half times 2/3 times 3/4 times all the way up to times 98 over 99 times 99 over 100. So it's like the same question really. And these values cancel each other. 2 cancel 2, 3 cancel 3, 4 cancel 4. 98 cancel by 98 before that, 99 cancel 99. You left with 1 over 100. All of that becomes, this is that the same question really. Becomes log to base 10 of 1 over 100. So I'm going to become negative 2 because 100 is same as 10 squared. So become log to base 10 of 10 to the minus 2. Minus 2 comes to the front. So become minus 2 log to base 10, log of 10 to base 10. This is 1. So the answer therefore is negative 2. That is the answer. Negative 2. Alright guys. Easy stuff. Easy. That was logs 2012. Alright, I don't think there's any more on it. That's 2012. Let's jump to 2013. All right, 2013. Let's look at 2013. 2012, 2013. Let's see what is on 2013. Might not get to anything today. 2013. Let's see. Add mass level work. You know it's on a pure mass paper. 2013. There's none on this paper. Surds logs indices. None on this paper. Look back at the first part here. All right, there's none on this paper. Yeah, come on every paper now, guys. The syllabus is a longish syllabus. Everything can come on. So let's look at 2014. 2014. 2014. Here's a nice question on 2014. I must get similar question to this. And here's another question. Oh, wow, all of this can be done. Everything right here. And here, A, B, C, and D. 2014. All right. B, C, and D, and 2014. All right, guys. B, C, and D, 2014. Let's go. First one is given that this thing equals that thing. Show that this equals that. That's a nice looking question, man. Show that this thing is equal to that thing given that information. Alright? So we have to use this somewhere along the way. Improving to this equals that. Alright? So they are using the laws of logs to rate this up and get that. That's what it's all about. Ready? Alright, so we have 3 log of a plus b over 2 equals log of a plus 2 log of b to show. When you want to show something, you see, you must take the left side and prove it equal the right side. That's how you show this thing, right? So starting with the left hand side. First thing I want to do the left hand side is move this 3 up here. So I want to use the laws of logs, right? And move up the power 3 first. And move up the 3 becomes a 4. Alright? Becomes a 4. Alright, it becomes a 4. Alright. So it becomes equal to the log of a plus b over 2 all cubed. That's what they get first, right? This now is the same as the numerator cube over the denominator cube. So it becomes the log of a plus b cubed over 8. But 2 cubed is 8, right? And I want to expand this. I'm going to expand that. A plus b cubed. I'm going to expand it. What do you get to expand a plus b cubed? Let's look over here. Expand a plus b cubed. I'm going to get a cubed plus, I get a cubed plus, I get 3a squared b plus 3ab squared plus b cubed. That's what we're going to get. Let's prove it. Let's prove it. That's what we're going to get. Let's prove it. Alright, so just that we don't do, yeah, let's prove it. It's good to know these things here. So just like when you know the expansion of a plus b squared, what he said, it's good to know this, a pyramid. You have to work it out. But let's prove it, let's prove it. So the a plus b cubed is the same as a plus b times a plus b squared, don't it? Okay? We'll expand the part here. So I'm going to get a plus b times a squared plus 2ab plus b squared. Which everybody know that this expands to that, right? And I'm going to use this now, multiply each of them. And then use the b and multiply each of them, right? When I use the a first, I get a cubed plus 2a squared b plus ab squared. When I use the a and these, that's what I get first, right? Got it? Then I'm going to use the b now on each of these. So I'm going to get plus the b times a squared. It's going to give me another b a squared like I have this, don't it? So I'm going to get plus a squared b, really, right? This time this is a squared b, don't it? And then I'm going to do the b times this. I'm going to get 2ab squared. Oh, I'm going to get 2 more of this. I'm going to get plus 2ab squared. Well, this times this, I'm going to get b cubed. When I add it all up, a cubed share this, and then b cubed, which is what I wrote. You write over this and erase it out. Oh, this is what I wrote here. So say this numerator becomes this. Let's write it. So this then becomes equal to the log of a cubed plus 3a squared b plus 3ab squared plus b cubed all over 8. What if someone must use again? Something else someone must use. They were telling us that a cubed plus b cubed plus 3ab squared is equal to 5ab squared. Alright? 5ab squared. Alright, watch this. What the question really said, you know, is that this and this, and which one? 3a squared b, and the one here, them three they equal 5ab squared. See that? That's what the question really saying, you know. Don't it? So I can replace those three that I've circled, 5a squared b, 5ab squared. Come over here, sir. That's what the question said. Given that equal 5ab squared. I'm going to replace those three that I've circled with 5ab squared. So this becomes equal to the log of 5ab squared for the three things that I've circled, plus about the 1 here left, which is 3ab squared all over 8. But this and this are the same thing, right? There are 5 of this and 3 of that. So it's 8 of them on the numerator, don't it? And so the 8 cancels. So this can be written as log of 8ab squared over 8. The 8 cancels. So then it becomes the log of ab squared. Voila. Log of a product becomes the log, sum of the logs, right? So this then equal to the log of a plus the log of b squared. And then the 2 can come to the front, and it becomes equal to the log of a plus 2 times the log of b, which is the right hand side. It is the right hand side. Let's tell us to show. See there? That's what we get. So I've shown that this equals that. So the key step in this question was just to expand the cube. First thing, simply enough, move up the tree. First we say we work in the left side. I'll take the 3 and move it up on the power. That's how we get that. And then I expand the numerator, the cube. Just that expansion gives us this. But then the question gave us this information to use. And so that's how I get the 5ab squared. And then the 5 and the 3 is 8. The next line. The 8 cancel. Leave with the ab squared. And then I use the law of flower. Open it up like that. Power 2 comes to the front right here. And then that is the right hand side. Alright, that was on 13 paper. Easy stuff. Just need to practice. Just need to practice. One question with exponential here for e to the x. But this guy's got that equation e to the x. But e, all the logs to base e. Alright, let's do this question now. This one. Watch over the video. We do the questions. We do the questions. This thing does need practice. So we have e to the x plus 1 over e to the x minus 2 equals 0. Naturally, I don't want this fraction. I'm going to multiply through by e to the x. I'm going to multiply through by e to the x. When I multiply this by e to the x, it becomes e to the x squared. When I multiply this by e to the x, I get minus 2 times e to the x. When I multiply this by e to the x, I get plus 1 equals 0. What an easy question. But this can factorize to a perfect square. Bam, 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 bam. E to the x are factors of this. All the factors of 1 are 1 and 1. Signs are the same, they are both negative. Minus minus equals 0. So e to the x equals 1. If e to the x equals 1, then x must be 0. Any power raised, any value raised to the power 0 is 1, don't it? That's all. 1 is the same as e to the 0. So you say x equals 0. Or if you like, you could take the log of both sides. ln this side and ln1. ln1 is 0. Anyway, take it x equals 0. X equals 0. Plus e to the 0 equals 1. X equals 0. Done. Next question. That's what that nice, easy, this guy's product equation. That's what I'm doing. See that there? Done easy. Done fast. Practice, you got here, guys. Practice, practice. This one, logs. Advanced level logs that. Difference inside here, so we'll take the quotient, right? This thing, let's zoom it up on this, right, straight across. So this thing becomes equal to log to base 2 of x plus 1 over 3x plus 1 equals 2. This number equals this base raised to that power 2. So end up getting x plus 1 over 3x plus 1 equals 2 raised to the power 2, which is equal to 4. We're going to take this and multiply across by the 4. We're going to get x plus 1 equals 4. X plus 1 equals 4 times 3x plus 1. Easy question. X plus 1 equals 12x plus 4. Bring this over here, so we get 11x. Bring this over here, so we get minus 3. So therefore, x equals minus 3 over 11. X equals minus 3 by 11. And that would work here, because that will leave that positive. And also will work here, because still that will leave that positive. So this is a valid answer. Valid. Can we put it? minus 3 over 11 there, so it's going to work out positive. Put the minus 3 over 11 there, so it's going to work out positive still, because the 3 times 3 over 11 is just 9 over 11, which is 1 here. So that is a positive. It's equal to negative 2 over 11. All right. And then we come to this question here. This one. We don't use our calculator. Show that all of this equals 10. So to do this question, what I would do, realize that this and this are reciprocal of each other. And this are reciprocal of each other as well. So let me say a word approach now. I would rationalize this and rationalize that and rationalize that. Rationalize all of them and then add them. So that if I rationalize this is reciprocal of it, right? And then if I rationalize this one, this is a reciprocal. There might be another way to do it, you know, which is to add these two. Add those two. And then add these two. Instead of similar values. I was looking at it guys to see which way maybe the easier way to do it. All right, let me rationalize this and then do this as a reciprocal. Rationalize this and then do that as a reciprocal. That's what I'm gonna do. Let's do it that way. I'm starting with this one. Rationalize the denominator of that one first. Root 3 minus 1 over root 3 plus 1. Multiplied by the conjugate. Times root 3 minus 1 over root 3 minus 1. See? That's a plus multiplied by a minus under there. Alright? So it becomes equal to, the numerator becomes a perfect square, right? It becomes equal to a perfect one in the numerator. This square give me 3. Then twice the product of the 2 give me minus 2 root 3. And the second term squared is a plus 1 over this squared is 3 minus this squared is 1. Alright? That's what we're gonna get. I'm gonna put one symbol by one, line them up beside each other. Line them up beside each other, this small, line them up beside each other. And let's add them vertically down. So this reduces to 4 minus 2 root 3 over 2, which divide further gives me, I can leave that in and add them up, you know. Rationalize one and it's rationalize all of them and add the results. Alright, write out the final value for this. This becomes 2 plus root 3. See that? 2 plus root 3. Right? And the second one is the reciprocal. So this time I have root 3 plus 1 over root 3 minus 1. I'm going to multiply the denominator by the conjugate, so times root 3 plus 1 this time, and root 3 plus 1 this time. Alright, so I'm going to get the denominator, the difference of 2 squares again. So I'm still get 3 minus 1 again. The numerator becomes a perfect square again, but with a plus inside of somewhere. See that? With a plus, see it? See that? perfect square, but instead of this with a perfect square, a minus, this is now a perfect square, a plus. So difference between now that this will have a plus in it. So we're going to have a 3 plus 2 root 3 plus 1. So the only difference is that this becomes a minus. Because it becomes this and it becomes a plus, sorry. No, this is supposed to be a minus, you know. It's supposed to be a minus. My mistake. It's supposed to be a minus. Minus. Right, that is a minus. So this actually becomes 4 plus 2 root 3 over 2, which then becomes 2 plus root 3. 2 plus root 3. So this one is already out of the 4. Alright, let's do this now, please. Alright, so we're out of these values. So let's do the next one now, which is root 2 minus root 3, sorry. Root 2, yeah, root 2 minus 1 over root 2 plus 1. Rationalize it again. Times root 2 minus 1 over root 2 minus 1. Rationalize the denominator equals. Numerator again is a perfect square. First term squared is 2. Twice perfect of 2 gives minus 2 root 2 plus 1 over, this is 2 minus 1. 2 minus 1 is 1. So this actually works out to be 3 minus 2 root 2. And you follow the trend, the other one is going to be 3 plus 2 root 2. But the difference between them is that instead of a minus 1, it's a plus in the next one. You can see it here, so the last one. We get root 2 plus 1 over root 2 minus 1. Rationalize the denominator. You're going to multiply by root 2 plus 1. So you put in root 2 plus 1 up here as well. And so this becomes perfect square again of these two, which becomes 2 plus 2 root 2 plus 1 over, this becomes 1 because root 2 squared is 2, 2 minus 1 is 1 under here. So this works out to be 2 and 1 is 3. So you get 3 plus 2 root 2 this time. And then adding up these 4 values that I'm going to underline, I'll put in a box. 1, 2, 3, 4. Add them up. All the surds gone. So you will add these values. 2 and 2 is 4, and 6 make 10. So it actually works out to 10. Those values add up to 10. Is what I said before to show. So this is just more practice to rationalize. More practice to rationalize. That's what that is. 2013, 2014. Let's jump to 2015. More maths equals better maths. Let's jump to 2015. I still want to look at that. Let's see. But everybody okay with that online?
Yes, sir.
All right. Remember, guys, key things for you to redo the questions. Redo the questions. All right. All right. Let's see. 2014, 2015. No, we're gonna stop. Somebody says we're gonna stop 8 o'clock. 2 hours. And then tomorrow, we're gonna have a session online tomorrow. I'm gonna give an assignment. I want everybody to do tonight, before the class tomorrow. I'm gonna start the class tomorrow by working through that paper. And then we'll do some more online. I work for about another 2 hours or so online tomorrow. Alright, so that is the plan. Alright, 21 minutes now, 2015. 2015. This might be the last one for tonight before I give you the work. Before I give you the 2015. going to go over here. $20.50. You want to figure out? Let's see if there's any on 2050. We did this question already the other day. See, it was on a different paper, but it's the same exact question, this one. Know that? We did this exact same question the other day on a different payment paper in 2019. Same exact question, this one. You can see that the actual repeat, see if you can find it. So that the actual repeat the exact question. Let me see. It's 2019. Let's see. Aha. Look here. Look at that. 2015 and 2019. Same exact question. Confirm. I can tell you that happens often. The people know the business of pyramids. Gotta repeat question a lot. Same exact question. Same thing. You get me? Did this question that I here. Alright. This question is actually a long question. This one. It says the population growth. Right, the population growth of bacteria present in a river after T hours is given by this formula. An indices question that is T. So what it's saying is that the number, the population growth, given by that formula after T hours. So when T equals at the start of the thing, what is the population? N equals 300 plus 5 to the power T. After T hours, that is the population. The population growth of bacteria present in a river after T hours is given by this formula. What is the number of bacteria present when T equals 0? How much? 300. I'm going to get 300. Yeah, 300. 301 because 5 to the 0. See there, part 1. When T equals 0, 5 to the 0 equals 1. So the n becomes 300 plus 1 equals 301. Next question. The time required to triple the number of bacteria. The number of bacteria triple much ago. The number of bacteria is tripled. How much bacteria got out? Oh, 903. When tripled, n equals 903. You're trying to find that time, you're trying to find t when n equals 903. See that? So the equation becomes 903 equals 300 plus 5 to the t. See that? Subtract the 300 over here, so you get 603 equals 5 to the t. What would we do after that to find t? What do I do after that? When the thing you want to find is in the power, you can bring up into the same place, you take it out, so get out of the power. It's a pure mass paper, so you take ln. You take ln of this side and ln of that side. See that? This t comes to the front right there. So we end up getting ln 603 equals t times ln 5. And you divide ln 5 under there. And so t equals ln 603 over ln 5. Whatever that report was at. What that result is the answer. And then says hours, right? I have to get them in hours. Yeah, get them in hours. Get them in hours. Another question. All right. Which one? This is what, 2015 to 2016. Let's look at 2016. Is there's anything interesting there? 2016. Let's finish start with 2016. And then I'll give you the activity that I want to do. All right? Do before class tomorrow. All right, foolishness. 2016, easy. Add mass level work this and a 2016 pure mass. When you add logs, you become the log of the product when they are the same base, right? So this becomes the log to base 2 of 10 minus x. Can I just write, can I just multiply these two things, this time this? All right, 10x minus x squared equals 4. Got it. Got it. So this is my number now. This is my base raised to this 4. This number equals this base raised to that 4. So 10x minus x squared becomes 2 to the 4th power. It's 16, right? So I'm going to take everything I'm going to over the side because I want my square term to be positive. So I'm going to get 0 equals x squared minus 10x plus 16. Factor of 16 at the 10 is 8 and 2, don't it? So 0 equals bracket, 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 bracket. X and 2 and 8 signs are the same. They are both negative. Negative, negative. So x equals 2 or x equals 8. Let's make sure both of them can work. Then put 2 years of good. Put 2 years of good. Put 8 years of good. Put 8 years of good. So both answers are valid. Both answers are valid. So you can beat those two other answers. So for example, one of my answer the report to be, for example, 12. For example. 12 can't work here, so. Because then I will find the log of negative 2. Can't find the log of a negative number, you get me? Good. I'm not finish it. I'm not pack up all that. Let us part here the question. Oh, part B. Get to it. Alright. Just an easy question on pure maths paper. Pure maths, you know? Pure maths. No people fail them exam, you know? That's so easy. Alright, I'm gonna bring up the paper that I want y'all to do now. Let's bring it up. Let's bring it up. And screenshot it and do it. So all these questions like some repeat, I could do them already. See there, that is the class activity, guys. I want you all to do. Easy stuff. On the right side of the screen right there. Classwork. We're gonna do it as a homework. Who do the question already? Do the first one already, second one already, maybe the third one yet. And we'll do the number 7. No, the one like number 7. So I'm gonna do the first one already, and I'll do the second one already. They're gonna do the third one. Do all of them still, do all of them. Do all of them. Alright? Screenshot it for me, please. Online people, screenshot it for me, please. Write the questions. Keep in the classroom, take a picture. Alright? In fact, let me take a picture and send it to you. Finish this question before the session tomorrow. Session tomorrow, 1:30. In 1:30 and 2 Jamaica time. In 2:30 and 3 Trinidad time. Or 2:30 Trinidad time. Yeah. I'm supposed to give a booklet. 2 booklets actually, one for this and one for Sunday. I know the Sunday booklet when we start. Start Sunday. Maybe yeah, next week and start the Sunday booklet. Start the right, sir. What's the number about it? Hello? 854 17 7 70. Let me want to know what happened. 566 98. I give you a number sheet. Number 536. All right. Remember that before or please serve us. Listen, online, class, the class over online. Sunday. No, when we start Sunday, so now we have class. So now we have class to start, right? I want to go online, Stop it. Yes. Bye, Kai. Bye, people online. Hello.
Alright.
Bye, sir.
Bye, sir. Bye, sir.
Got the screenshot of the question, right?
Yes,
Yes, sir.
sir.
All right, I'm gonna send the video. As soon as I get it to you guys, can use that revise. Redo all the questions, please.
All right, sir.
Alright, sir.
All right.